Hi, this is Maggie. In this video, we'll talk a little more about what you can do with strings, including string formatting and string processing methods. Strings are how text is stored in a Python program, and text is ubiquitous in computer programming, both for communicating with the user, as in menus, button text, and instructions, and for analyzing and processing human communication. We'll begin with formatting, which allows us to construct a string by interpolating other data into the string and controlling how that data is interpolated in. We'll write a little program with some string formatting to demonstrate. Suppose I want to calculate a weight on Mars, and I begin with a weight on Earth. I'll need to divide that weight by 9.8, acceleration due to gravity on Earth, and then multiply by 3.7, which is the acceleration due to gravity on Mars. Chances are I'll end up with a pretty messy number. For example, if I take something that weighs 20 pounds on Earth and divide by 9.8 and multiply by 3.7, I get 7.5510204081632266. I'll probably want to truncate that when I report it to the user. So I'm going to pause the video and write a quick program without the output. I'm going to obtain weight from the user, and I've put Mars weight in a variable. Mars weight equals weight divided by 9.8 times 3.7. And now here's how I recommend you start out with string formatting. Usually you're going to be doing something with the string, like storing it in a variable or printing it. We'll put this in a print statement so we can see the result when we run the program. So print open paren, and then I recommend you start by writing out an example of what you want the output to look like. Let's say I want the output to look like an object that weighs 20 pounds on Earth will weigh 7.5 pounds on Mars. Now that's just an example, of course, because the user probably won't enter 20. Where we have the 20, we want to substitute in the value referenced by weight, and where we have 7.5, we want to substitute the value referenced by Mars weight, and here we've made the decision to have a precision of 1 decimal place. Where we have the values we need to substitute, we place curly braces inside our string. And then after the string, we write dot format. And in parentheses, we list the expressions we want substituted into the curly braces in order. So that's weight, comma, Mars weight. Now, if I run this and enter 20, I get the messy output. But notice that my spacing looks good. This is because I wrote out exactly what I wanted and put the curly braces where the variables get substituted. With some practice, you can do this without writing out an example first. You just need to remember to put spaces and punctuation exactly where you want it. Okay, there are many codes we can put inside the curly braces to exert some control over how that data is interpolated into our string. We'll look at this documentation in a moment, but let's start with some simple codes to get the control that we want. Both of these variables, weight and Mars weight, are floats. inside the braces, we can write a colon followed by F, F for float. Now that won't change the output. It will look the same. But if we write 0.1F, that will format each float to 1 decimal place. Let's run the program now. We enter 20 because we know that gives us a result with a long decimal part. And we can see that our floats are formatted to 1 decimal place. The result, the Mars weight, was rounded. That is going to take care of a lot of the formatting that you will need in displaying output. The other sort of formatting you might want to use is formatting as a table. Let's format a table with 2 columns, Earth weight and Mars weight. Now let's first do this with the formatting we know now. And I'm going to hard code in some weights and do the calculations right in the format statement. So first I'll write print open curly brace colon S close curly brace open curly brace colon S close curly brace dot format Earth Mars. The S stands for string. That's for the headings for the columns. And then I'll do, say, 20, 40, and 60 pounds. So I'll write print, open curly brace, colon, 0.1 F, close curly brace, open curly brace, colon, 0.1 F, close curly brace. Dot format 20 divided by 9.8 times 3.7. And I'll pause the video and I'll put in the columns for 40 and 60. Now, when I run that, the columns don't line up at all. The way to get columns to line up is to specify a width. The width will be the number of characters set aside for that value. And any characters that aren't used by the value will be padded with spaces. So I'll modify the headings to read colon 10S, and I'll modify the floats to read colon 10.1 F. And then one other thing I can do is add an alignment so everything is aligned within those fields. I'll add a less than sign after the colon. That will left align the values in the columns. And here's the result. As promised, here's the documentation. And you can reference the first line of this specification to see the order of the different alignment codes. Read on to see all of the different codes. We've only covered a few here. You can practice with that, but for now, we'll move on to some string methods. Strings are a collection data type, like a list. A string is an ordered collection of Unicode characters. And so there are a few things we can do with strings that we can also do with lists. As an example, here in the console, I'll pass a string to the len function. and you can see it returns the number of characters in the string. I can ask if a particular character is in a string using in. And that expression evaluates to true or false. I can index into a string to retrieve a particular character. And I can slice a string. Those all work the same as they do with lists, except that lists are mutable and strings are immutable. I can index into a string to get a character, but I can't write over a particular character. Now let's define another string and then demonstrate some string methods. First, there are some methods that will return a copy of this string, but in some altered form. So for example, we might want to convert our string to all uppercase or all lowercase. This would make it easier to perform a case-insensitive comparison. Because strings are immutable and these methods return a new version of the string, we must assign the result to a variable to have it. So I'll write upper Monty equals Monty.upper, and if we ask idle to evaluate upper Monty, you can see that our string has been converted to all uppercase. The original string, Monty, is unchanged. Similarly, we can use lower and this converts our string to all lowercase. We can strip whitespace off our string. We can strip off just the beginning, just the end, or both beginning and the end. Again, because strings are immutable, we must assign into a variable. We can assign back into the same variable if we don't want to keep the original string. I'll assign no space Monty equals Monty.rstrip. When we evaluate no space Monty, you can see it's had the white space stripped off the end. We'll do the same with lstrip. And you can see that it strips the white space off the beginning, and then strip which strips the white space off both ends. White space is the space, tab, and new line character, so this is handy when reading from files. Now there are some methods which will check if a string is all numeric values, all alphabetic characters, or a combination of numeric values and alphabetical characters, but those aren't as useful as you might think. So I'll define a string with just numbers in it. And I'll ask, is digit and idle evaluates that to true, and I'll ask, is alpha, and Python says false because those are digits and not alphabetic characters. I'll ask if my no space Monty is alpha, and notice Python evaluates that to false. That's because there's still a non-alphabetic character in there, the space between the words. And if you think about the symbols that might be in a number, such as a positive or negative sign, a decimal point, maybe a comma, these methods can't be used to determine if a string is a text sentence or a numeric value. So, limited in value, but still occasionally useful in data analysis. Now, some other interesting methods that can look into a string include count, find, and starts with. The count method takes one argument, a substring, and it will count the number of occurrences of the substring within a string. We'll create a long string. This is from the national poem, The New Colossus by Emma Lazarus. Give me your tired, your poor, your huddled masses yearning to breathe free, the wretched refuse of your teeming shore. Send these, the homeless, tempest-tossed to me. I lift my lamp beside the golden door. We'll use count first. Suppose we ask idle to count the instances of your in the string. Our string is called Colossus. We write colossus.count your, and idle tells us 3. So you might notice that it's a case-sensitive count. You might also have noticed from the tip that came up when I typed the name count that I can specify starting and ending indices, so I can count within a slice of my string. Let's look at find. Let's find the word free. So I type colossus.find free. And again, you notice that I can specify a slice to search in. This is useful if I want to continue a search from the location of the word. So we find one instance and then we want to continue to search from there. So idle tells me 71, and that is the index of the first character of the word we were searching for. If I ask idle to evaluate Colossus 71:75, which should be the substring starting at 71 and up to but not including the character index 75, I find the entire word free, as expected. Finally, we'll look at starts with. This will return a Boolean result. Does this string start with a particular substring? So Colossus starts with give is true. And again, I can specify a substring to search in or just a location to start searching. So that's a lot of information about strings, and there's a lot more that you can do with them. You can look through the Python documentation and experiment. For now, I recommend you practice with some strings of your own. Try formatting a table with different kinds of data, and then try these different string methods on strings of your own. Predict the results and test in the console. You might consider writing a string processing program that obtains a string from the user and reports facts about the string that you've determined using these methods. Once you can format your output as you want and predict the outcome of these methods on different strings with perfect accuracy, you're ready to move on.